Hello everyone, so my name is Dawei Chang and I'm from MeDA lab, which is a medical data analysis lab. And I'm also a PhD student from data science degree program at National Taiwan University and Academia Sinica. And so before we start, I want everyone to try one thing. So I think everyone has a link to the slides of this whole workshop, right? So please use this link to find this folder, which is medical image segmentation, and this is our first section. And here, please choose, please open this file, so which is liver slide segmentation.ipython notebook. So yeah, please. Oh, okay.
Sorry about that, but please, every participant, click your Wi-Fi and search that Wi-Fi name. And the password is 2312345 yeah, it's NTUH Hospital's telephone number.
Yeah.
Please make sure that you connect to that Wi-Fi, okay?
Yeah, so because if you want to open this file, you need to use, this file is put online and we are connected to the Google Colab, which is a workspace provided by Google. So you need to use the Wi-Fi to connect to this file. Okay, and later we will do our demo in this file. So yeah, please connect to internet. Okay, so please try first whether you can open this file. And if you have a problem, please try to solve it before we go on the hands-on. Okay. Okay, so let me back to the main topic. Okay, so this is our first section, which is called medical image segmentation. And so yeah, so I will give an introduction about what we will do in this whole workshop. So we will have 5 sections, and I will give some introduction. And then I will go through our main topic in our first section, which is medical image segmentation. And I will do some introduction, and I will introduce a method to do the medical image segmentation in computer. And then we will have the hands-on. Okay, so if you find you are interested in today's content, or you are interested in the technical detail, or you are interested in the medical AI, so our lab has a branch called MeDA School, and you can access it through medaschool.ai, and you can find some useful resource here. Yeah, so we have some tutorial on medical AI, including the overview and the technical programming. Yeah. Okay, so now we'll start to introduce what you will learn and what you will see in this whole workshop. So this workshop is around the topic, which is called medical AI, or medical artificial intelligence, or smart medicine. Okay, so first, let me introduce what is AI. So we say AI for, it's a very popular term recently. And AI means we want to let the computer or some machine to mimic the behavior of human. So let's say we want them to have the intelligence created by human. So it's called artificial intelligence. And so medical AI means AI using medicine. So we use AI in medical field to solve the medical problem. And later you might hear some terms about machine learning or deep learning. So it's a kind of technique to solve the problem of AI. It's a method to realize AI. And machine learning is the it's a kind of technique to let computer to learn the knowledge by the data itself. And deep learning is a special case of machine learning, so which means we use neural network to learn the task. And you might ask why we need medical AI. So we think medical AI can help doctors to help people. And so because AI is performed by the computer, so the computer can break some limits that human has. So AI can point out some subtle parts in your medical data, like the very small tumor on the image. And this kind of tumor or this kind of sign is very easy to be missed by the human naked eye. So yeah, by using AI, it has a chance to let the human to notice that there is a small tumor. And this can help doctors to achieve a higher precision and accuracy in diagnosis, and especially when the disease is at the early stage. And another advantage is AI can screen, monitors, and summarize a large amount of data and 24 hours a day. So it won't be tired, it just need to eat the electricity. So human will be tired, so human should be used in a more valuable way, like the doctors should more focus on the decision itself, not the daily routine. And the last one is AI can provide a new type of measurement to help the clinical decision. And we think this kind of measurements may enhance the ability for the precision healthcare, or you can find a suitable solution for each individual. Okay, so then what you will see in this workshop. So we will cover some concept in the core components of medical AI. So we will have some concept in medical AI in medical image, like medical image segmentation, which is this section, and medical image classification, which is the next section, and the medical image registration, which will be the third section. And we will give an example in the non-medical image application, so which is the ECG analysis. And then we will have a topic, a training topic, which is generative AI. So if you don't know the generative AI, you can think it's a kind of field about like ChatGPT or Midjourney. So okay, so we will cover the generative AI in medical context, and it would be the generative AI in medicine and healthcare for our last section. And the most important thing is we will provide the hands-on to let everyone to have some concept about how deep learning or how AI is work in the computer, and maybe you could get some idea from it. Okay, so yeah, so again, welcome everyone to this workshop. And for now, we are going to formally start our first section. So the first section is medical image segmentation. And first, I will give some introduction. So first, we should have introduced what is medical image. So the medical image means the image generated from the medical procedure, or sometimes we would call it medical imaging. And medical imaging is a kind of technique to generate image for human to observe the human body, or yeah, any kind of body. Okay, and so this kind of image can visualize the body structure or functioning, and it can provide some clinical information or use for clinical analysis. Okay, so later we will use CT as example. And CT is a kind of computed tomography. It's a kind of technique to use X-ray to observe the inner body, and it can show the anatomical structure, and it can also show the abnormality like tumor or any other kinds of structure. Okay, so next we will say, so we are medical image segmentation. So what does segmentation means here? So the segmentation means we want to find a meaningful part in the image. So for example, in the top image, we will see it is a photo. And we want to point out that, oh, here is a car, and here is a road, and here is a building, and here is a sidewalk. So the segmentation would be look at like the below image. So like in below image, we will point out that, okay, there is a car here, there is a car, could I change the color? Nope, okay. So there is a car here, there's a car here, and there is a fence here, there is the vegetation here, and there is a building here. So look at this image and let computer to recognize which part should be yellow and which part should be red. And this kind of task is called segmentation. Okay, so in medical context, the medical image segmentation means we want to find some meaningful regions. And this kind of regions could be like the organs or the structure, like tumor or bones, a section of bones and so on in the medical image. So like in our today's example, we would like to find the liver in a CT slice. So this is a CT slice, and there are many organs, and the liver is here. So we want to let computer to color this area as liver. So the right-hand side, we provide figures to show there is many kinds of situation you can use medical image segmentation, and you can do lots kinds of things. Okay, so we have introduced what is medical image segmentation, but why we need to use medical image segmentation? It's like, so for humans, we can easily to see where is the organ. So why we need computer to do so? So here is the reason. So we need computer to recognize where is this organs or where is this interest area, because we want to use this for further analysis. So like in clinical usage, it can be used to design implant, to planning surgery, to detect lesion, or it can use for tracking the abnormality. And the important one is for further AI analysis. So like if you need to use human to circle out the organ first and then put it into AI, it will somehow be human library, and it is not the thing we want. So we want the model, we want the human free from the library. So we want the model to do, we want to use AI to do some library thing, and segmentation is one of this kind of thing. And so in our previous work, we use segmentation to serve as a pre-processing of classification. And so this framework can be used to detect whether there is a pancreatic cancer in CT. And we would put the CT into a segmentation model, segmentation AI model, to let AI generate a segmentation of pancreas. And then we will use another AI model to analyze whether there is a tumor in this area. And then we can tell the doctor whether there is a pancreatic tumor. So yeah, so in this case, the segmentation is play a very important role for circle out where is the pancreas. So yeah, so this is an important reason that why we need to use segmentation for the machine learning or for AI development. Okay, so for now, you all know what is medical image segmentation and why we need to use it. But before we start to talking about method, we would have a look in the image itself. So because we want to use computer to run the AI, so we need to know what is the image in a computer. So in computer, an image you look like this. It's actually stored by an array. So a 2D image like this one is stored in a 2D array. And of course, the three-dimensional image is stored in a three-dimensional array. So an array means we put the values or put some numbers into order it into like a square or a cube. And every pixel, which is, if you zoom in this part, you will find it is formed by many little small squares. And this small square called pixel. And every pixel is represented by a value, which means the brightness or the color. So in this example, we use 0 to represent the black area. So you will find every small square here would be marked as 0, and some square on here would be marked at other value, like 0.643 is brighter than 0.526. Okay, so actually this small 20 by 15 pixels rectangle region is represented by this two-dimensional array. And so you can imagine, actually this whole image is represented by a huge array of these kind of values. Okay, so what is segmentation means again? Okay, so actually in a computer, the image segmentation means we know each pixel has its value. So we want to use this value to decide whether your interest area is inside this pixel. Like so, which pixel represents liver and which pixel represents background. And in this example, and this small area, so this small area, we would say this part, so this part should be liver. So we want to mark these pixels as liver, so like mark it as 1. And we want to mark the other part, the background, as 0. And by marking this image, which means we do the segmentation, and we will get this kind of image, which contains only 0, the purple part, and 1, the yellow part. And this image called segmentation mask. So the segmentation in computer means I give you an image. So I want you to find this segmentation mask. And this segmentation mask has the same number of pixels as the original image. But it has to point out which part is the interested area and which part is not. Okay, so before everything starts, okay, so I think we can go through some introduction about CT here, because later we will use CT as our example image. So CT is the abbreviation of computed tomography. So it's obtained by measuring the attenuations of X-ray by different tissue in the body. So it's like every pixel in this image can represent a kind of substance. So if the pixel shows it is like negative thousands, it means there is air in this pixel. And if it is between about negative 120 to negative 90, it could mean this pixel represents a fat area. And if it is 0, it is water. And 20 to 100 means soft tissue, and compact bone has H value, or the pixel value here is larger than 300. Okay, so you will find actually the actual value could be very wide range. So if I directly plot out a CT slice, you will see the image like the left-hand side. So its contrast is not quite well, and so we cannot find the detailed structure of the soft tissue in this image. So actually, we will do some windowing technique to clip out the parts that we don't want. So it's like we will put the actual value, which is under like negative 200 to 0, and it will increase the contrast of the image. And finally, you will see the image on the right-hand side, and it will be clear for our human to observe this image. So it's like it's the original CT slice, and you can find the value has a wide range from like negative 700 to like 100, positive 100. And after doing windowing, we will clip this part all into 0, which means here is air or something that is not the soft tissue, and we will put other value in other parts, so it could make the image has a clearer contrast. Okay, so for now we are ready to introduce some method for doing the medical image segmentation in computer. So in computer, if we want to do the medical image segmentation, we can use a row-based approach, which means we manually assign some condition to filter out the pixel that we want. So this condition should be very specific, like pixels that are bright is not a good condition. It should be pixel with this value larger than 0.9. Like it should be very specific. And here are some example types of rows here, and you can read it after this workshop if you have interest in it. And the main issue of such kind of approach is that it is very difficult to find a universal rules that can apply to every input image. So I will show you this kind of problem later. So okay, let's try to use row-based method to segment liver from this image. So first, let's consider to use a threshold to filter out which part of the image is like the soft tissue. So we could use, is the pixel larger than 0 or larger than 0.6 or 0.05 or 0.95? And you can find when threshold is set as 0, you filter out almost everything. And this is not the thing we want, because we just want to filter out the liver. And like 0.5 is also not a good choice, because the liver part is disappear under this threshold. So we can screen it, and maybe we think the 0.65 is a good choice for the threshold. So because if we use this threshold, it can filter out the liver, and the liver is split from other structure. So because the liver is split from other structure using this threshold, we can further do some kind of techniques to remove other connected component and preserve the largest one, and which is liver here. And finally, we can use some technique to fill in the small hole of this segmentation mask. And finally, we can get the acceptable liver. Okay, so for now, we establish a rule to segment the liver. So first is to choose the pixel with its value larger than 0.65. And then we preserve the largest component here. And then we fill the holes. So here we generate a rows, or we call algorithm, to segment the liver. And okay, for now, let's see whether we can use this rule to segment liver in another CT slice. So here is another CT slice, and you will find it fails to generate the liver segmentation. So if you dive into the row itself, you will find that it fails because the threshold is not suitable for this image. So 0.65 is not suitable for this example. The more suitable one would be 0.45. So here points out the problem. If I change the case, I have to adjust the rows so that I can do the things we want. So it's not satisfied with us because we don't want to let human to adjust this threshold for every image. So at the end, we will use the deep learning approach to do the liver segmentation. And machine learning or deep learning approach is to let the computer to learn the rules by themselves, not by we telling them the rules. But if you want to let the computer learn the rules, you have to pay something out. And here you have to provide some example to show whether it is a good liver segmentation. And so here I write down some terminology that you will hear in the deep learning. And you could examine them after this workshop. And I will directly use this figure for explain how deep learning is doing. And so first we have to prepare our training data, which means we will use this data to teach the computer about how to do the segmentation. So like this is the question, it's a CT slice, and this is the answer. It should be a liver segmentation mask. And we will also give the computer a model architecture. So you could imagine model architecture is a kind of template which has many blanks for a computer to fill in. And by filling the right number in the blank, it could do the segmentation. But if it fills in the wrong number, it cannot do the segmentation. So to find the right blank, or we will call parameters or weight in deep learning, so we would use a training process to find these parameters or weight by input the training data and observe whether it is performed well using the function called loss function. And then we will use optimizer to update the parameters or weights to make this model better. And repeat this process. Finally, we will get a good model that can perform the liver segmentation well. So in the testing case, if we get a new CT slice, we can just put it into the trained model and we can get the liver segmentation. So this is how deep learning works, and we will show it in later hands-on. So here are some pros about deep learning, like you can use the general architecture like an NUNet, so you can do many kinds of segmentation tasks. That means you don't have to pay your time to select the architecture. And you don't need to adjust the algorithm case by case. You just need to train one model, and it can do it for the whole case. And after the model is trained, it can do a very fast segmentation for a new coming data. But it also has some cons, like if you give the model bad training data, it can provide you the bad model. And like the training model itself can take a lot of time and computational resource. And there are also some general issues for deep learning, like we don't know what model is actually doing, so it lacks of some explainability. And it's also a problem that whether this model can perform well outside of your training data. So, but anyway, deep learning is a very powerful technique for image segmentation. So we will use it in our AI nowadays. Okay, so for now, I just go through all the introduction of segmentation. And for now, we are going to have a demo about how to do the segmentation, really do the segmentation in the computer. So I think you have accessed this link. And you will see this. You will see these windows. And so first, please click on File here and click Save a Copy in Drive. Okay, so by doing so, your change will be saved in your drive. So if you directly run something on this original notebook, so the change won't be saved. Okay, so here is a copy of the notebook and it's stored in your drive. So if you modify it, you can save this, you can preserve your change. And for now, we are going to do a very complicated process. Okay. So now we are going to set up our environment for execute this program. So please click on Runtime and change runtime type here. And make sure you are using the runtime type Python 3 and using the hardware accelerator as T for GPU. So if you do not set this thing, you will find your training process will be very slow. Very slow. Okay. So yeah, please check this part. And after you check that, you can start to run this notebook. And before you run, you have to prepare the data. So here you can find the link here. So under the title, prepare the data set here. And you can click this link, and it will lead you to a file. So you don't need to download this file. So for now, please click on this icon here. Here might be a wait. Okay, it shows something that is different from yesterday or today by, oh, okay. Okay, so that's something not happened. And okay, let's do it again. Okay, so if you open this file, you could find there is an icon here, which it means create a new shortcut into your drive folder. So please click this one and put it directly under your slide, under your drive folder, which is this one. And so if you do this correctly, you can find there is a file directly under your Google Drive here. And now we can back to our notebook, and we will want to mount the drive into this notebook so we can access the file here. So please click on the icon here. There is a folder icon here. And here is the button look like this kind, this icon. And if you click on it, it will ask you run the cell to mount your Google Drive. So run the cell. So if you want to run the cell, just click the play button at the left side of the cell, or you can use Control plus Enter to do so. Okay, so run this, and they will act the permission, and just give them the permission. Okay, so it will take some time to mount your drive into this notebook. And if it correctly, you can click this button to refresh the folder on the left-hand side. And you will find here is a drive folder, and here is my drive folder. And under this folder, you will find the files in your Google Drive. And here should be a file called demo nifty.zip. And after doing so, you can run this cell. So this cell will extract the zip file into our workspace. So if your file is not put directly under the My Drive here, so you have to change the path here to the correct path of this file. But yeah, you can just put the file just below your drive. Okay, so after doing so, you can run the next cell, which we want to install a package called MeDA, and we will use this package to process our medical image into the kinds that we can put into the deep learning model. And yeah, after you install the MeDA, now we can import all the packages we want to use in this example. So here are many packages we want to use. And it would take some time to import all the packages. Okay, so far so good, okay, so does everyone successfully to this step, or is anyone need some help? So you means repeat the previous step about how to put the file into your drive? After that, okay. So after you put the file into your drive, please click this button. And after you click this button, it will show this cell. It will create a cell here. And you can click the run button here. Click it. And it will ask you to give it permission for mount the drive. And just click I agree. Yeah. And okay, and after doing so, run this cell to extract the file into the workspace. And if it done successfully, you will see there is a demo Nifty here will be created inside your workspace. And then you just need to, if you see a cell, just run this, and you can do everything later. Okay. Okay. So for now, actually, you can click run time and click run all, and don't see any code here. You can also find it will run out some results. But here I will execute the cell one by one and explain what it is doing. And I won't do the detailed explanation. So if you are interested in the technical detail, you can see the explanation on this notebook. So first we will prepare our data set. So like we have prepared a data list here. So we will load it into our notebook. And you will find there is 131 data in this data list. And every data is formed by a path to image and path to label. So this means the CT slice we want to do the segmentation is put here. And its ground truth segmentation, which is the answer, are put in the label, this file here. And now we want to split it into a training set and a testing set. So because we will use the training set to train the model, and after doing so, we have to use a set except the training set to test whether our model is performed well. So we have to hold out a testing set from the training set and execute it. So we will split 104 data into training set and 27 data into testing set. And for now, we are using the MeDA transform to transform the file name into the real image and into an array that can exactly put in the deep learning model. So you can just click the execute button or run button. And here we prepare some function to plot out the image. So just click run. And now we can test what we do in the transform. So for testing transform, we will just read out the image and we will change some spacing, but I won't explain this detail here. And you will find, so this is the original image, and this is the ground truth segmentation about liver. Okay. And for training transform, we do some tricky thing. So you would find there is a 4-patch crop from the original image, and its corresponding cropped segmentation mask. And if you rerun this cell, you will find it will give you a random new 4 crop, new 4 patches. So this is because every image has different size. So for some technical reason, we want our input data have the same size. So to solve it, we will use a technique called sliding window inference technique, which means in the training stage, we will randomly crop the same size of patch from the image, and we only do the segmentation in this patch. And in the testing case, we will extract all the patch by slide the window. So we will have many patch. And we will do the segmentation on each of these patch, and then we form all the segmentation result back to an image for a whole segmentation. So you will find in training transform, we will have it will generate 4 randomly chosen patches. And okay, so now we can use this transform to generate our data list. So click the run button, and it will start to generate a cache data set, which would be more efficient for our training process. And we can define a data loader based on our data set. And data loader means we can use it to take out the data from the data set. So for training loader, we will take out the data from training data set. And for testing loader, we will take out the data from testing set. And now we are ready for preparing the model training. So after dealing with data, we can deal with the model itself. So for now, we are defining the model, which is called UNet here. And we use this hyperparameter to establish this architecture. And we define a loss function here, which means dice loss. And we would like to define another thing called optimizer here, which is Adam. And yeah, by click the run of this cell, you can define this thing. And here is a demonstration of how we really do the training. So we will run for many epochs. So for epochs means we will run over all the data for once. And when we run over the data, we will try to update the model and make the model more better. And after running all the data once, we run the model over one epoch. So the epoch is 10 means we run for all the data set for 10 times. So just click on it, and the model will start to train. and just wait for it to train. Yeah, just wait. You will need to take some time to make it run over 10 epoch. And if you think the 10 epoch is not enough, you can rerun it after it run over, and you can do another 10 epoch to get the model trained for 20 epoch. And if you just rerun it again, you can get the model for 30 epoch, and so on. And you can just change the epoch number here for training more epoch, and you may get a better model. And so if you want to reset the model, you can rerun the cell upside here and then run the training process here. So I have add some notes here so you can refer to it. And okay, so for now we train the model for 10 epoch, and we can evaluate how this model performs. So here we choose the first data, which is called the 0, 1 data, and run it. So yeah, you can find here is the original image and original label, and here is the original image and the model predict label. So you can find, okay, after 10 epoch, the model can capture where is the lever, but it somehow also capture other structure. So this is not quite well here. So you can try to train another 10 epoch by rerun this cell. So yeah, you can wait for another 10 epoch. And after doing so, you may find your model perform better in this cell. So I can just click the run button, and it will start to wait this cell running over, and it will run this cell. So yeah, please wait for a second. Okay, so yeah, you may found that it still circle out some other structure, but somehow its performance seems better. Yeah, and finally we can run this model over all the testing data. So we have many testing data, and for each data we will run the model to generate the segmentation, and we will use dice score. I put it in the supplement here to evaluate whether our segmentation performed well. So here our model reached the dice score 0.73. So this is not a quite well result, but yeah, this is your first step to use deep learning for the segmentation. And if you try to adjust the parameter inside this code, like if you train a model for more epoch, or you change the patch size of the sliding window inference, or the overlap parameter here, you may get a better result. And actually, by using this code, you can get the results like here. So if you train your model properly, so for like here I trained the model for 200 epoch. And if you adjust some parameter inside the sliding window inference function, you can get a quite well segmentation of lever. And your dice score could be like 0.94 or 0.95. Okay, so finally, if you find you want to just find a trend CT segmentation model, and you don't want to face the code, you can find it here, which is called Total Segmenter. And here is a demo website here, and here is its GitHub. And if you are interested in the state-of-the-art medical image segmentation technique, you can start from the NNUNet. Its publication is shown here, and it is its GitHub repository. Okay, so this is the end of the first section, and thank you for your attention.